Let's start creating a new project. So we'll be specifying the path of the project where the files will get stored, and then specify the name of the project, and then we also need to name the top level design. And then just click next, and we don't have any files to add here, and we need to set the device parameters here. And just select our device family, next, and we need to specify our simulation tool here, and just click finish. So we have successfully created a new project. So we need to go to tools and then click on qsys. So we need to add the components here. So let's start adding the components Nios, and then we are using the economical version, and then on chip memory, and the memory will be 8K. And then we need to add the component JTAG reward. We don't need to make any changes. And then we need to add the performance counter. Finally, we need to make the interconnections. So clock and reset will go to all the components. So make sure that the master is communicating with all the components here. And then we need to assign the base address. Go to reset vector and then click on chip memory, and also for the exception vector just click finish. Now you need to generate the bit file. Just save as your top level entity name, and then click on save. And then it pops up some messages. And we can see there is no errors in that. Just minimize it and go to quarters. We need to add files to the project. So we can see the .qap file which can be imported to the project. Just click add and then give apply. So we can see on the left side, we can see that .qap file. Go to assignments, assignment editor, and then we need to add the clock here, and then we need to set the assignment name as location and IO standard, and for the clock the pin number is pin L1, and for IO standard it's 3.30 TTL logic, and just save it. We can see that the computation process is performing. We can go to the Eclipse now. we need to select the workspace here, so we can specify the path where we have saved the project. Just click OK. I'm going to make a new folder here. So we can see the Eclipse window here. So we need to create a new template here, and we need to specify the SOPC information file which is stored in our project. So go to desktop, log on to software, and click the SOPC file, and then you need to specify the project name. Say for example Oru underscore project software, and then we need to specify the project location, which is our default project location that we stored on the desktop, and just we need to click on the C file that we are going to run it. So we can see that template has been created. Just click on the hello world. Let's see, we can see our program here. So this is the code for the FAR filter. We'll copy and we'll paste on the template, and we also can see that the compilation is successful. We'll paste here and we will run it. First we need to build the project, and then we need to run it on the Nios software. So before that we need to open the programmer, and we need to set up the hardware. So click on the SOF file and then go to hardware setup. You can see the USB blaster here. Just click close, and then start. You can see that the file has been added successfully, and just save the CDF file. Now we can start building the project. We will run it as Nios 2 hardware. Okay, it's compiling now the C code. Okay, so we get the computation time as 0. I guess we didn't set up the base address in the program. So we need to change the base address. Just click save. and then build the project again. And then we need to run as Nios2 hardware. I guess I have saved in the run in the commented lines. I guess. Okay, let's go back and do it again. The base address is okay. It's 5,000. Let's see the comparisons. Yeah, okay. So we have the filter output here on the computation time.